and today he's going to talk about how to make a good app, basically, because our team said and thought there are a lot of new developers that are just starting their journey on the way. So Cezary is going to speak about his experience and what he learned, and what can also be a good trick for you to learn if you want to be a good developer, especially for the start. So another thing is that this webinar is getting recorded, of course, and you can have a copy of your recording. And the second thing is, this is the last webinar in the series, but no worries, because we're going to have a special gift for you. It's going to be a super surprise, so please stay tuned, because it's going to be really cool. So Cezary, now I guess the floor is yours. Break a leg. I'm going to mute myself.
Okay. Hello, everyone. Welcome to my webinar, in which I would like to share with you my reflections about software development. I would like that this webinar have this form that I will talk about my journey throughout my personal development as a developer. So, first of all, short introduction. My name is Cezary Haliniarz. I finished biomedical engineering and electronics. This is important. I don't have degree in computer science. I work on commercial projects for around 3 years, mostly in JavaScript. Also, I worked in 4 completely different companies, and also I trained several sports throughout my life. So my journey as a developer started in university, I would say. As I mentioned, I didn't study computer science, so I hadn't such many subjects around programming, around architecture, databases, and stuff like that. Of course, I had some basics, but still, during my studies, my code looked like this. So it was complete rubbish, no separation, and bad naming. Everything was the mess. So yeah, I even went on a short intern during my studies, but unfortunately, they learned me how to write the code, but not how to write a good code. So after studies, I started my first job. I would say it was a startup. And then I learned about Pareto principle. Most of you probably know what it is, but in the software development, it means that 80% of the whole software you can do in 20% of the estimated time. It means that in this 80%, all the functionalities are covered. Software is working, but I would say it's not well written. So why should we bother about this remaining 20%, even if it takes such a long amount of time? I would say that if you want to work with the software, your software more than around 2 weeks, you probably should bother, because in this 20%, remaining 20%, there is all the things which make code maintainable and easy to evolve. Here is hidden, for example, good architecture, clean code, and stuff like that. So, of course, if you want to prototype something quickly, you don't have to bother about remaining 20%. I know that, for example, startups or data science software houses are doing only 20% because they only want to quickly check prototype, quickly check idea, or build a minimal viable product, just to be sure that they go in the right direction. But they should, after checking this idea, they should, of course, throw everything away and just start from the scratch with the good basics. And yes, and here back to me, I am in the startup. We are completely working only on 80% of the software. And I'm really youngster. I want to develop. I want to extend my knowledge. And I started thinking that, okay, maybe it's not the best idea to work only on this 80% of the software. I started to feeling that it's not the good way to develop myself. So after a few months, I quit and started looking for a new job. And I went to the software house, and I would say it was my first real job. And this software house was completely, like the idea of making the software was completely different. So in this software house, they were strongly concentrating on this remaining 20%. And there are still people who are crazy about the good code. So, and here I am. I came here without any knowledge how to write a good code. And yeah, I started working. I write a few commits, and they said, "Oh my God, man, you don't know nothing about how to write a good code." And they sat with me for hours, try to learn me basics of how to write a good code. And first thing, I believe for every developer and every person who wants to learn how to write a code is a book written by Robert Martin called Clean Code. The main idea behind this book is that everything you write has to be understandable for every developer. For example, there are many teams and members of the team are changing, and each new person coming to the project has to understand the code someone wrote. Why it is important? Because when the code is understandable for everyone, it means that it is just simply stupid written. So if the code is simply stupidly simple written, it means that it's really easy to evolve, to change, to add new functionalities, to do anything with it. So what are the main ideas in this book? I would say, of course, everything simple. Also, every name should be as descriptive as possible. I believe describing these rules it will be the easiest way to describe with the function, because, for example, function has name, which should be short, simple, but also very descriptive. For example, I ask myself when I'm writing the name of a function, what does this function do? And when I can come up with a solution, with a with a response that, okay, this function do this, it means that I have simple name, and also the function only does one thing only. And this is really important because it makes functions short and make function do only one thing. Also, we should test everything, like really everything. So, and also tests and code, of course, also should be self-documenting. We don't leave any comments in the code, for example. And there is this rule that we should always leave the code better than we met. Also, there is one rule which I believe is maybe for youngsters in the programming the most important, that we should not be afraid of changing the code. So if we see something is really hard to change, to extend, to maintain, or we don't understand what is in the code, we should really think about changing it, and we should not be afraid of it, because we have so many frameworks, so many tools to keep our code updated, to keep our code with these tools, reverting the code is really simple. So we should not be bothered by and afraid of changes. And why should we bother about writing a clean code? Because software tends to rot. Throughout the time, code gets worse and worse, and it's really bad for maintaining the code, of course, for evolving it. Here's a short example. For example, we have really simple functionality to get some display name. And there is the new functionality coming, and that we should
Guys, sorry, we have a technical issues. If you hear us, we're very sorry. We'll be back in a moment. Okay, guys, so we're coming back to the stream. Sorry for that. It's going to last a couple more seconds, so we have sorted it out. Sorry for that once again. So yeah. Yeah. Now I see that it's going to continue. Okay, fine. We have the picture back. One more minute, please. Sorry for that. Okay, guys, can you please in the comment section say what was the last thing that you remember was said? I mean, yeah, okay, thank you. I see something's writing. No way. No, never. So I hope it's okay if we start from the software rot and software entropy. Okay, so in the meantime, maybe, guys, you have a couple of questions about what is going on. How do you like it so far? You can leave your comments. The last thing I heard was about Pareto principle. That's really well. Perfect. Okay. We're trying really hard. You don't see it, but there is a backstage team of 2 people, and they're trying to fix it very hard. So I'm trying to not to look at them because they're checking everything right now. I think you can also hear them whispering. Actually, maybe it's a good idea if you do it on my computer because it's working.
Yeah, maybe it's a good idea.
Yeah, so please give me a moment. I will prepare my computer for that. Yeah, so that's the presentation.
Yeah.
Yeah, I have it on my screen right now. So you can use it.
Okay,
Yeah, thank you. Okay, show must go on. Please take my seat.
Yeah, sorry for that. Yeah. I was stressed before. Now I'm really like totally stressed. Yeah. Where? What was the last?
share my screen, and guys said that the last thing they remember was Pareto principle.
Okay, but you're not sharing anything.
No, I'm not. You have to do
Okay.
it yourself.
Okay, no problem. Hopefully,
Don't show anything else.
I will try really. Yeah.
Okay.
So as you can see. Okay, Pareto principle. Yeah, I talk a lot of things after this. So, so yeah, but so in the shortcut, I went to the startup in my career journey. I went to the startup, and here I heard about Pareto principle. So we are doing only 80% of the software. It means that all the functionalities are covered, but we don't do code really good. Like, well, we don't care about good architecture, clean code, and stuff like that. So this is the idea of creating code in the startups, and I believe when they're creating minimal viable product, and also in the software houses connected with data science, because they are just trying to check single idea. Like single idea, if this idea is correct, and they throw everything away. They start from the beginning with the good foundations. So yeah, this was me in the startup. They were really creating only 80% of the software, and I thought that okay, it's not maybe best idea for the youngster, and I really wanted to develop myself in the different direction. And after a few months, I quit from the job and went to a software house. And in the software house, they were really have different idea of building the software. It means that they were crazy about writing good code. And I went from there with zero knowledge how to write a good code. And I started working, I made a few commits, and after checking my code, they said, man, you know nothing, and you are really rubbish developer. So, and they sat with me and started working with me and started teaching me how to write good code. And first thing for every want to be software developer person is to read a book, Clean Code. It's written by Robert Martin, and the main idea behind this book is that everything has to be understandable for every developer. For example, if a new person is coming to the team or members in the team are changing, every new person has to understand a code written before. Why? Because if the code is understandable for everyone, it means that it's really written simply stupid. And it means it's really easy to extend the code, to change it, to maintain it, everything. And what are the main rules behind this book? There are many of them, but in the shortcut, everything has to be simple and descriptive. So in the end, we end with a code which is self-documented. We don't leave any comments, and everything is short and simple. For example, functions, if we think about functions, we have to come up with a name which is really descriptive. It means that it describes what this function does. For example, I ask myself the question, like what this function does. And if the answer is really simple and singular, I know that this function will have good name, and also this function is correct in the terms of the clean code. Also, we want to test everything, like everything, and also tests should be written really simple in the simple way and should be self-documenting. There is this rule that we always have to leave the code better than we met, and it means that we should not be afraid of changes. If something is hard to read, hard to understand, or we don't understand, or we don't know how to add new functionalities, we should not be afraid of changes. I believe there's something that young developers are afraid of changing the code of the seniors. and they should know, because we have tools which make reverting the changes really, really easy. And why should we bother about clean code? Because software tends to rot and tends to become worse and worse throughout the time. Mostly, I believe, throughout from my experience, I would say that software become worse and worse because people are afraid of changes, and people are afraid of changing someone else's code. Also, sometimes the code is really good tested, and we don't want to change the test. So we add functionalities in the stupid way, not about thinking how to do this good in a good way. Here's example. We have really simple function which displayed the name, but the new requirement come, and we need to add, for example, honorifics. It means that we want to display doctor or professor at the beginning. But after some time, we have new functionality and new functionality to add. And we end with the really horrific function, which is long. And it's really like it's not covering anything fabulous, anything hard. It covers really simple functionality, but it's really hard to read, hard to maintain, and hard to understand. I would say that new person will come and what is it? How it's working? So yeah, in this scenario, someone should ask themselves the question: why it's so complex? Why it's so complicated? Maybe I should write a new abstraction, start from beginning. It would be really a good idea. But why should we bother also about software which is rotting throughout the time? Because it costs us money, and it is not a good idea. This is the real example from the book, also written by Robert Martin. In some company, they want to release new versions, and of course they're hiring new staff because new functionalities have to be implemented by someone, and also the code which is already written have to be maintained. So with each release, they hire new people, but it turns out that with new people coming, the lines of the code written between releases is not increasing. Like it's increasing, but really slowly, and in some point it just stops. There's no new code between versions, and what does it mean? It means that we have really messy code, and the code is rubbish. And it means that with new releases, new versions, we do not add functionalities at all. We just maintain old code, or we are just moving rubbish from one place to another. And like new people are coming only to maintain the old code. As you can imagine, it's not good. And also it means that cost of a single line is increasing really rapidly. And after some time, probably this product will be killed because there isn't a way to add new functions, new functionalities, new things to it. How we can stop it? One idea is to test everything, of course, despite writing a clean code. So writing a test. Here's an example of the guy who decided to write a simple function with using TDD idea. TDD is the system in which we write tests before functionalities itself. It means that before writing code itself, like writing functionality, the code. Test is also a code. We write tests. It means that we have to think about implementation and etc. etc. And it turns out that this guy was able to write code, this single functionality, quicker using TDD. And despite that, TDD means writing more code because. So you can ask questions why. I believe from my perspective is that because TDD and testing over generally help you organize your thoughts. Like when you're writing the tests, you really have to go deeply in your problem, deeply in your functionality you have to write, and it helps you organize thoughts and help you like really think about what you have to do. Also, testing help you write less buggy code. Also help you add refactor code or add new anything really easier, because you will know when you broke the old code, old functionalities. So it's really helpful, and it's really needed when you want to make maintainable code. So this was the basics. The next step, I would say, in the developer development is learn design patterns and architecture, good architecture. There are two things which are really big topics, and separately it could be the webinar for a long time. And this is why I would like to only shortly describe what it is. There are many books about it. Of course, you have to. I advise to read them. So, design patterns. Design patterns are general solution for repeating problems, and they're really good if you meet some problem really often, and it will happen when you write the code. For example, here we have really simple design pattern called strategy. It means that you close some of the functionalities in the separate objects or classes, or how you want to say it. So, for example, here on the left, you can see that everything is written in the spaghetti way, that everything is written in one place, but you can close these functionalities in the separate classes, and then you just call function in the specific class. And for example, you don't care about in this example, you don't care what tool you are using. You just want to call specific function on tool which you are currently using. It really helps you organize the code, and the more design patterns you know, probably the better code you write. The next thing is architecture. Architecture is really big topic, and I'm thinking that I'm learning it now, currently in my software development process. So I would say that we are writing architecture in the layer way. So we have different functionalities and different stuff covered by layers, and the highest layers are responsible, for example, for the business logic. So there we are only thinking about what software should do, and not how, only what. And with each layer going to the bottom, we write the code which does something, and there we are thinking about how it should be done. Things like databases and infrastructure are on the lowest layer, and we should not bother about this at the beginning of writing the code. Some developers tend to start from choosing the database, and it's not the best idea, because, for example, after some time you decided, okay, maybe I should use another database, or maybe you don't have to have database at all. For example, I don't know, client wants to print the results to the text file, for example. And really good idea is to not be dependent on that. Layers are not dependent on each other, but of course it's not possible. So we tend to depend things which are not changing really frequently. Things which are changing really frequently depend on the things which are not changing frequently. For example, business logic is not depending on anything. The other things are depending on the business logic because business logic is not changing frequently. The next thing is that, especially in the JavaScript environment, we tend to be working with many frameworks, and we tend to be really dependent on the framework. We write the code in the way the frameworks make us do this, and it's not really a good idea because frameworks are changing really quickly. The frameworks can die in some way, and for example, we are left with the code which is really close to the framework, but the framework is dead. So we have to really rewrite everything, or we have to choose different framework, and it's not a good idea. Yeah, but these are really technical issues. But what about writing the code itself? Like, why should we write every time the code in a good way? Because we have mechanics called automatism, it means that we tend to we do some stuff really automatically. We don't think about it. A good example are sports people, because they practice one single movement for a long time for example, Michael Jordan was playing basketball all the time. Like each time he had some free time, he played basketball. He was throwing ball to the basket over and over and over again. But can you imagine that he was practicing throwing the ball in the wrong way? For example, he was throwing next to the basket. It's just stupid. So I believe we should not write bad code over and over, because it will make us write the code automatically. It means that we will start to write bad code even without thinking about it. Okay, it's bad code. This is why I would say that working with Pareto principle, but on this bad way, that we write only 80% of the code for a long time. It's not a good idea, especially for young people who start working as a software developer. Okay, so because of my personal issues, I have to change the job, and I went to another software house. And I would say I met another problem, which is the client. Because in the previous work, I was working really closely with the client. I was partner with the client, I would say, and I have never experienced deadline atmosphere. I have never written the code in the rush. I was really just focusing on writing good code. And here I comes to the current company called BinarApps, and I met the client, and I met the deadline. So yeah, just you can imagine, I was new in the company. I have my first project. It was a really small project, but with the fixed deadline. I really want to write the code in the best way I could, but when I was getting to the deadline, it turns out that I have 3/4 of the code written, and it was really shocking for me, and it was really nervous for me. After talks with the client, with managers, we decided to take some shortcuts. I was not happy with this, but this is the client's idea, and this is the world we are living. The clients are probably more important than good code. And I was thinking how we can manage it, like how can meet the requirements of the client, on the good code, and the developers who want to write a good code. And currently, I only come up with the good communication, that we should be over communicating about this, and we we should really strictly say that, okay, it will take me more time than you could think about it, but it's because I want to write a good code. And this is because, okay, we will finish this part of the project, and he will come to me the next month to write a new part of the project. And I don't want to work with the bad code. I want to write this part the best I could to be able to work with the next parts really easily. And I don't want to have the bad work to the bad code. So for the conclusion, I would say that that the title of the presentation was how to write a code which will cost you the fortune. And I would say that if you have too much money, you can write a really not clean code on the bad architecture without any tests. And yeah, we'll see how it will come up to you. Probably you will lose your money, but I would say that taking any shortcuts in writing good codes is a really bad idea. And it is because, as you can see, the single bug, for example, in Amazon cost them a lot of money. And in the long perspective, writing good code is really it's always comes with the benefits, and the bad code always strikes back with costs or with frustrated developers or any other employees. Okay, thank you very much. I believe it's time for Q&A session. If you have any questions, because of our technical issue, I don't know how to check where is the code. Okay, so what is the most important thing in the clean code? I would say that the most important is to keep everything simple. There is this rule, even KISS, I would say, keep it simple, stupid. Yes. So I believe it is the most important idea, that if everything is simple, it's probably easy to understand.
Okay, I think I should be back now. Okay, thanks a lot for a wonderful presentation. It was really cool, especially like we did this episode with the thought of you guys, new developers that are coming to the branch of IT. Okay, once again, sorry for the technical issue, but it's like Spanish Inquisition. You know that one. No one expects those. So, you have any questions? Because I don't see the screen. No? Yeah, I think there is one. Yeah, perfect.
The books, no. No, most of them are paid, so you have to buy them. Sorry.
Someone else typing?
But I recommend, especially every book written by Robert Martin for the beginning they are the best.
Are they somehow related to George R.R. Martin? Is it a different one?
No, it's not the guy. I was really afraid that I will mix them.
Okay, I saw that someone was also typing his or her question, but it is not yet available. So let's give it a couple of seconds more just to make sure that everyone who wanted to ask the questions, ask those. By the way, coming closer to the developers. Yeah. So a step forward towards the development.
Yeah,
My career.
maybe this format that we are talking with Rada is better than.
I can't say. Okay. What did I want to say? Yeah, seeing no one's typing. However, guys, if you would have any question which falls and pops up in your head afterwards, don't forget that there's something. Don't forget that you always can text us in our BinarApps. So we are very open towards your questions. Okay, another one.
Why do you think software developers often do not follow good design principles? I would say it's because they don't think about writing they want to have solution really quickly, so they just write the code, write it as quickly as possible without thinking that, okay, maybe I should organize this code in a different way. And I was in the companies, for example, I believe it is because you have the task, and for example, you have 8 hours for this task, and you really want to make it in the 8 hours. Don't think about, okay, maybe I will write it in for example, 2 days, but they want to make it in a really quick way.
But what is the symbiosis between the developer and the project manager like me, who says, okay, you have 8 hours for the task? What can we do?
I would say that you should be kind for developers and understanding for them, because especially if at the beginning they are really afraid of anything, and they want to be the best, but they sometimes don't have knowledge, don't have idea, and they don't want to ask too many questions, especially to the more experienced developers.
Mm-hmm. So building an atmosphere of trust.
Yeah.
Just a quick hint. I think it's going to be a spoiler. It's the topic that we might be addressing in future with our special bonus for you lovely guys. So if you're interested in that, please follow us and don't miss out for new hotter topics.
Yeah. Oh yeah, we have another. I don't know.
Yes,
do people see these questions?
Yes,
or
they do.
Yeah, because maybe I'm just reading it without.
No, you're doing fine.
Okay. So how can we learn writing good code apart from the books? Of course, writing the code. Yeah. Yeah. Reading the books is like, I would say, I don't know, 10% of the learning. After reading the book, or even during the writing the book, reading the book.
Read the book and then write the book.
Yeah. You should write as much code as you want, as you can. For example, I don't know, you learn about new design pattern. You should test it on the real code, on the real life examples. And of course, if in the books there are examples, I suggest writing in the computer, writing, because first thing first, like you really concentrate on it, and also you can come back anytime to it really easily. So just build your, like, I would say, map of thoughts, but with the code.
I wonder, what is a good method here? I mean, okay, you read a good book, you say, okay, now I know stuff, and you start coding. And what do you also do? Do you do refactoring? Do you do code reviews to make it better?
I would like, if I see something new in the book which I have never seen, I try to find some tutorial with it in the internet, just to see someone's code with this example, and then I try to find the similar situation in my own code. For example, most of the people have project from previous companies or previous.
Which you Control-C?
Yeah, and you see this is some situation, and then I see, okay, in this tutorial we have this kind of factor, we do this on the living code. So yeah, and also I would say that reading too many books in one stand, it's not the best idea, because you will not remember everything. Like read, I don't know, 20 pages a day or things like that. Not try to read whole book in one night, because you will not remember anything from it.
Now we have another question now from. I'm sorry, I don't have glasses. Where can you please help?
Yeah.
Okay. Yeah.
How to convince client?
Well.
Oh.
Yes.
Yeah. This is this is the trickiest question, I would say. Just tell them that the good code is, in the long perspective, good code is always better. If you want to work with this code more than a month, for example, it's you should really bother about writing in good shape with the clean code. And if the client does not understand it, like I don't know how to convince it. Maybe some examples, real life examples. I believe there are many in our area. So find any example in where bad code killed the project. I believe there are many.
Yeah.
And of course, this example I wrote about Amazon. It was like 40 millions for 1 hour. I don't know that Amazon is like the biggest company you can imagine, but if you think that Amazon have budget, for example, for some part of the money, and you have 10 times smaller or 100 smaller, the cost of the $1 probably will be in the same proportion. So I would say.
Well, it's a funny thing, because I did a webinar about costs of that. Yeah, but
yeah. You can ask Lenka about how to convince and how to ask her about examples where bad code killed the project.
Yes, actually, as for this year, we actually try to speak with the client and make him understand. It's not because we want more money. Actually, it's because better code has better maintainability, and it's like in the long perspective, it's much better. However, always keep in mind that if you fail, it is still the decision of the client. It is very hard truth. It makes me cry when we do compromises, if we do compromises, but it is still, if you fail, it is still his and her money, or the client's money, and that they make this decision. You make everything to make sure that they're making good decision, but you're not the client, unfortunately, and they must decide what the money should be spent on. We have more questions. Fantastic.
Any resources to help me make my code cleaner? Of course, this one book, Clean Code, I would say it's like the Bible of clean code. I believe that even this book introduced the term clean code. Maybe I'm not sure, but I think it is. So this book, and there are thousands of tutorials in internet, like thousands. Of course, tutorials on the YouTube, tutorials on the many websites. Yeah, and maybe someday we'll start with, I don't know how it's called. Oh, sorry, I lost the word. We'll start with
bootcamp.
Bootcamp or training about clean code. So then we can learn you, but teach you. But I would say tutorials from the internet are the best.
Which tutorials? I'm sure there are different quality of the tutorials.
Yeah, it's always the problem. On the YouTube, check the number of views.
Okay, and see if there is like from Cezary. If there is a like from Cezary, it's definitely a good one.
Yeah, and of course read some comments below the videos, because there are comments if it's a good idea or bad, or there are sometimes discussions if, for example, some people decide, would do this another way. So it's also a good resource.
Okay. I see there is a comment suggesting that
start read the code on GitHub, find some good repo and dig into the code. Yeah, of course, it's a good idea. Really.
Yeah. Or go to Stack Overflow and Google your problem.
Yeah, I would say don't check my GitHub because it's rubbish.
Okay.
Yeah.
What about this project that we wanted to finish?
It's not on the GitHub, so most of the clients' repos are not on the GitHub, or they are private repos. So you will only see some projects from studies and from beginning of my journey.
Okay. I see.
Oh, yeah.
Someone switched it over.
Our friends cut us off, so we have to end.
Okay, guys, thanks a lot. It was really great fun being with you today, and big applause to our presenter. Cool. Yeah, support from the backstage also did a good applause for you all. Stay tuned. Actually, as I said, it was the last webinar of the series, but it doesn't mean that we will not have a second season. So finishing our series, I want to remind you that there might be a very interesting bonus in a different format. So stay tuned, stay connected, and once again, it was a great season being with you. And I think we will be also continuing this in the future. So, by the way, if you have any questions at all, as for previous webinars or this one, don't forget that you can always, Google us and ask us anything. We're really open towards your questions. Yeah, I think that was all. That's all, folks, as you know. So take care of yourselves, and of your relatives and close ones. Okay, bye guys, it was really cool. Bye.